Hi, this is Mark Kemper with EMS. In this video, we're going to 3D scan some bottles. Now, as you see here, bottles come in many different shapes, sizes, and complexities. So the first thing we'll do is set up and 3D scan a few different bottles. We're going to use a couple different scanners and show you the scanning process. And then we're going to talk about the downstream applications that you can use that scan data for. So things like blow molding, packaging, design of the packaging for marketing, things like that. Redesign of bottles where we take something existing, scan it, redesign it. We can also look at inspection, design for filling machines, things like that. So we'll walk through some of those different applications that you can use a 3D scanner in the bottling industry.
So what we're going to do in this video is we're going to cover the 3D scanning process, and we'll show a couple different bottles being scanned with a couple of the scanners. Then we're going to show a quick CAD modeling application and what that would be used for. Then we're going to go into a more of a feature-based CAD modeling process and show what that typically is used for. And then we're going to actually show 3D scanning an actual bottling machine to do some part design or redesign. And then we'll get into part and mold inspection, where we'll actually scan a mold or a part and actually do some dimensional inspection on it. And then finally, how you can use 3D scanning for things like design review, marketing, advertising, and things like that. So these are the subjects we'll cover in this video.
For this demonstration, we are going to demonstrate the Peel 2 3D scanner and the HandySCAN Silver Series, which is the 307 and the 700. And the reason being, for this industry, it's really a great value. Depending on what you're doing, you can get into 3D scanning at a really affordable rate using one of these two 3D scanners. So a lot of our customers, this is just a great fit for their needs.
So the first step in the scanning process is we're going to need to do something with the bottles, because bottles are typically translucent, whether it's clear or kind of a cloudy color. That presents a real challenge for 3D scanners. Basically, the light pattern, whether it's laser or structured light, is going to pass right through that bottle or diffract all over the place. So what we typically do is we just take all the labels off the bottles and we paint them with just white primer or gray primer, and we paint them so that they're a light color, nice light flat color. Now, there are scanning sprays out there you can use, and some of them disappear, but it's usually overkill for this and expensive and messy, and usually we don't care about painting these bottles. So typically we'll just paint them flat white, only takes a few seconds, and primer dries very quickly. All right, so to start the scanning, we'll show first the Peel 2 3D scanner. Now, this is a structured light scanner which projects out a structured light pattern. And one of the advantages of this scanner is it does not require targets. Now, in this setup here, though, you do see us using targets. And that's because this bottle really doesn't have a lot of unique shape to it. It's just kind of round and smooth. And it's hard for the scanner to line up the scans when you have a shape like this. So we have this little Lazy Susan, and we have these vertical bars, and they just have targets on it. And that helps it very quickly target as you move, or track as you move around. So you just move up and down. It's like digital spray painting, and you just work your way around. Also, we've got the bottle flipped upside down on a post. That allows us to scan the whole bottle in one setup. We don't have to flip it over in this case, and we can just move very quickly, as you see here, and scan it. Now, if you want to learn more about the Peel 2 and the HandySCAN in this video, in the description below are links to in-depth demos where you can learn all about the scanner. But with a setup like this, we can scan this bottle in a matter of minutes just by going around and just making sure, in this case, we're getting everything on the threads and moving up and down until visually we see we've got all the data. But it's very fast and it's very simple. Okay, so next let's show the HandySCAN Silver Series, which is the 307 and 700. Now, these are laser-based scanners, and they do require targets. But again, having our rig set up here, we can drop our bottle in and start scanning. We do not have to put targets on the part. And again, if you want to see more in-depth demos on these scanners, in the description below are some links to some very detailed demos. But it's the same thing. We call it digital spray painting. We just move around. One advantage of lasers is they do a better job picking up challenging surface types. They can also get in and get more detail. So depending on the type of bottles you're doing, or maybe you want to do other things, the HandySCAN may be the choice for you. But we just, again, keep moving around. Now we have the bottle just sitting here on the table. So obviously we cannot get the bottom of it. But what we'll do is we'll move around and we'll scan as much as we can. Here I'm in the single line mode, which is the HandySCAN 700. That's a feature in the 700 only. And that helps you get in even tighter in certain small holes and fine detail areas in that single line mode. But again, you just keep going around it. You can stop at any time, look at your scan data, make sure you have everything that you need. And once we have everything in this setup, what we'll do is we'll tell the software to add a second scan, and we'll flip the bottle over and we'll scan the area, basically the bottom of it. And then as long as we get a little bit of overlap between the two sets of scans, then right in the software that comes with the scanner, we can align those two data sets and then merge them together. And you could do this with 2 or 3 or 4, or as many scans as you want. But typically it's 2, maybe 3 scans to scan something entirely. But this gives you a lot of versatility. Depending on the shape of the bottle, it may not be easy to fixture it up in the air in a way like we did with that first bottle. So simply scan it, flip it over, scan it again, align the two data sets, and then there's some cleanup tools that let you get rid of all the extra data that you don't want. But again, having a little rig where we can just put the bottle in literally will let us scan just about any bottle in probably less than 5 minutes. Once we get it painted, we just put it in here, scan away. So we can do this very quickly. And this doesn't have to be an engineer who runs a scanner. It really can be anybody. There's only a handful of commands you really need to learn to run the scanner. But that's all you got to do really to scan a bottle of really just about any complexity or any size. So here is the scan data from 8 bottles and a cap that we scanned. And we were able to do this in about 30 minutes time with either scanner. So as you can see, it's very fast to be able to 3D scan bottles and capture the 3D shape. And you can see we've got a wide variety of small to large and even a small cap here. And this data is right from the scanner. It hasn't been smooth or manipulated in any way. So next up, what we're going to cover is quick modeling. And specifically, we're going to show how you can use this to quickly build CAD geometry from 3D scan data. All right, so let's take a look at one of our scan files. And for this exercise, we'll use the large water bottle. So you can see here's the 3D scan data. And it's going to be an exact replica of whatever you scan. So obviously this bottle had a few dents in it, which we're going to pick up. But we really don't care for this exercise. It's close enough to what we need. The problem is scan data is not CAD data. Scan data is just polygons. So if you zoom in here and take a look, it's all just a bunch of little triangles, okay? And in this case, it's over 1 million triangles. The problem is most CAD systems cannot work with scan data. If you import it, you usually can't do anything with it. You can't measure it. You can't really work with it as if it was real CAD. Now, we just need a quick CAD model. We're not going to go in and feature-based solid model it like you're going to see here in one of the other applications. We just need a quick model. And the reason we need a quick model is we want to then take this into the CAD of some of our bottling, filling, capping machines, whatever it may be. And we just want to have a model in there to represent the size and shape so we can start checking things on our machine to make sure, this is going to work, or do we have to make some adjustments to the machine? Do we have to change some of the handling equipment? Those kind of things. So what we do is we run a command called auto surface. And this is Design X we're showing here, but you can do this in VX Model. You can do this in Space Claim. You can do this in Geomagic for SolidWorks. And basically what you'll end up with is a solid body. Okay, so I just turned it on. We're not going to run it. It takes about 5 minutes or so to calculate it. But let's turn off the mesh for a minute. And you can see what we get. It's an exact replica of the scan data, but it's now these little NURBS surface patches you see here. Okay. And there's different ways you can run the command. It just, depending on the shape of the bottle, it's just basically breaking it up into four-sided little surfaces, filling it all in, and it gives you a solid body. Okay. So what's nice about this is we don't really have to do anything. We just make sure our scan data is pretty clean, and then we just tell it to auto surface it. Takes a few minutes, and then we end up with this. Okay. So if I turn off the edges for just a minute, you can see it looks just like the scan data, but now it is a CAD file. And what that means, and you can see here, it's a solid body. Now I can export this as IGES, STEP, Parasolid, basically CAD formats, okay? Where if I just try to work with the polygon data, all I can output is like an OBJ or an STL file. And those are just polygon mesh formats. So again, the idea here is we can bring in a bottle, clean it up, surface it up, and then solid model it, and then export it as a CAD file. And then we can bring that into our CAD files that we have built for our different handling equipment, filling machines, bottling machines, whatever it may be. And we can start using that very quickly to look at our design. So this would be great where you've got an existing machine. Now you're going to a new bottle, a new design maybe, or you've got a new customer that has a bottle, but maybe they don't have any CAD of it yet. So what you could do is, if they have a sample bottle, quickly scan it and then integrate it into the machine and make sure everything's going to work. You can do animations. You can do whatever analysis you need to do with that. You can even get the properties off it, like the volume, and see how large the bottle is and things like that. So it's just a great way to get a really quick surface or solid model of scan data that you can, again, integrate with your existing bottling, filling, capping machinery. Okay, so next let's talk about more of a feature-based solid model, and why would you want to do that over that kind of quick surface model. Well, let's take a look at this bottle here. And again, most of today's bottles are very, very thin, and you can see we've got a few dents in it, but overall we've got a pretty good shape here to work with. And what we want to do is we want to reverse engineer this back to a feature-driven model for a couple of reasons. One is we're actually going to redesign this model. We're going to take some of the styling elements off of it, but then we're going to change things up. Maybe it's a competitive bottle, maybe it's an older bottle, and the customer just wants to change it, and they don't have any CAD for it. So we've obviously already 3D scanned it, but now we're going to do what's called a feature-driven model, which is more typical of how CAD, CAD files are made, and probably how this probably was originally made. So here's our scan data, and I'm going to just roll back through the tree, but let's first show what the solid model looks like. So here is the original, or I should say the new bottle we built. So if I hide the scan data for a minute, so you can see this is all of our new bottle. Now we have some of the same styling features, but you can see we've changed others. Okay, so we just went through and kind of followed some things, but not everything. Okay, so there's our new design. But let's go back to this. So how do we do that? Well, in this Design X product, I'm going to roll back. It uses history tree modeling, just like many CAD systems today do. And, you start and build sketches and, work your way up through the history tree. So you can see here, let me just turn on some of this stuff as we go. So I start with the basic shape and I extrude it up. Let me show some of the sketches, and I'm just building a series of sketches. So I built one down here, extruded it up. Then I built a series of others, and I did some lofting. So you see I've got kind of my basic shape here. And what we're doing is we're basically sampling or cutting through that scan data. But at any time, we can, change our design. So here's the bottom of the bottle. You can see I've put the cut in there. And let's bring the scan data back on. Okay, so you can see I'm kind of following that shape. And let's roll forward a little bit. So you can see I've extruded that. I've thrown the radiuses on there. And then up here on this front, I want this styling element. And you can see this one kind of blends into the bottle. So what I did is I built a surface that kind of mimics that shape, and then through a series of, let's roll forward a little bit, through a series of, cutting profiles and trimming them, I did that. And then I'm starting to work on some of these other, and I'm just extracting data from the scan data and then building solid model data. And we have lots of great demos you can go watch that go into a lot of detail on how DesignX works. So you can see I've extracted those shapes, and then I'll mirror them over to the other side. You can see here and so forth. So I am building a intelligent model that you can roll back through, make changes to. Let's just roll down a little bit more here. Lots of fillets and so forth. So I'm just, again, I built this shape in here. I added the little sun. Oh, let's turn off. That's our mold, which we'll get to in a minute. But you can see, let's roll all the way to the end. Okay. So if you've used products like SolidWorks or Fusion 360 or CATIA or any of those systems, so even though some elements I kind of followed the style or the shape, others I did not. Okay. So I kind of loosely followed it to get the basic shape, but then kind of added my own design elements. And then once that was all done, let's hide our sketches. Okay. Now I have my solid model. Now I can start building my tooling. Let's turn the other side on. So we'll use this bottle to design our mold. And you can see I've got my two halves here. And, once I have that solid body, I can extract and, do all those things to build the tooling. And I can also do some rendering, which we'll cover later. But again, this is your more of your traditional CAD modeling. The difference is, again, we're using a product like DesignX, SpaceClaim, VX Model, Geomagic for SolidWorks, all which can work with scan data and build feature-driven solid models. And typically you would do this when you actually want to redesign it and then, build your tooling. Where the quick surfacing is just to get a CAD model we can just use as reference. But if you're going to redesign it, do tooling, do some other things, this is the method you're going to want to use. Okay, for this next process, we're going to change things up a little bit. We're not actually going to scan the bottle. We're going to actually scan the filling and sorting and packaging machine. So the same way you can scan individual bottles, you could go out on the shop floor and scan one of your bottling or filling machines, okay? And you don't have to scan the whole machine. You just got to scan the areas that are of interest to you. So what we have here is, you can see, just an area of a machine. Now, why would we do this? Well, let's say some of these parts on the machine need to be redesigned for different bottles, different equipment, or maybe these parts are wearing out and you can't get replacements anymore and you don't have any CAD, or you'd like to find a new vendor. Whatever the case may be, you can see what we've done here. We've just scanned this area here, and then using that same DesignX software and doing that same feature-driven solid modeling, we have built some solid bodies, okay? So here's the pieces I needed, and we just reversed engineer them, just like you saw with that bottle. We build sketches and extract them from the scan data, and we just go through, and I'll just kind of walk through and show what we did here to build these different models, okay? And, one of them is just a copy. This one here is then just copied over here. But you can see now we can go and have these parts cast or machined or whatever downstream application we want to use. But we just start by scanning the machine or the areas we want, and then we can go in and CAD model. Because again, you cannot send the scan data to somebody that doesn't have a product like SpaceClaim, DesignX, VX Model that can work with scan data. So you've got to build CAD for your vendor that's going to maybe recreate these for you. Or they could buy the software and do it. But if you have the scanner, you can go right on the shop floor. You can scan anything out there, any kind of handling or sorting equipment that you want, and then we can redesign or design them as needed, and maybe even make changes to them. If certain things don't work, you can make changes. So that's how you can use your 3D scanner to go out and scan your actual machinery to do some reverse engineering and CAD modeling. So next up, we're going to talk about inspection of both the tool and the bottle itself. Now, certainly doing inspection on the tooling itself makes total sense. once you've designed your bottle, like our redesign we did here, you'd want to inspect that tool to make sure the tool is accurate. And, we've got lots of videos you can go watch on doing inspection of tooling. But what if we want to inspect the bottles themselves? So obviously the tool may inspect just fine where it's accurate, but what if we have problems with the bottle? Specifically, as we mentioned earlier, the trend is to make these bottles as thin as possible to save on, obviously, material, not only for cost, but for environmental reasons. Well, that really means you've got to get very creative in your design so that you don't have a lot of deformation, because as you thin out that material, there's a good chance the bottle's not going to hold the shape well. It could deform easily. They can dent easily and so forth. So here's our scan data, here's our CAD model, and let's show our scan data. So what we did was we scanned the bottle after we took it out of the mold. And you may not be able to see, but it's somewhat obvious. You can see we have some problems. And a lot of this is probably related to our design. If you remember the original design, it had lots of ribs in the part. And that was probably to try to get the bottle to hold its shape, not only when it's empty, but obviously when it's full of a liquid. So what we did was we ran some first articles in the blow molding machine, and then we 3D scanned them to see what they look like. So here's the scan data of that. Let's turn on the CAD file, okay? And then the first thing we did was a 3D compare, and I'm going to show you what that looks like. So what we're doing is we're comparing the scan from the actual bottle and the tool, the mold itself, and what we should see is green, or a lot of green, hopefully. And to do that. So let's say our tolerance is 50 thousandths of an inch, okay? Let's turn on the tolerance map. So everything in green here is within 0.05 inches, okay? And it kind of makes sense kind of along the top and the more rigid areas, but you can see what's happening in the middle of the bottle. And it's primarily because of our design, okay? And if I hover over, I can actually see how much it's off in certain areas. So, and if I turn the tolerance color off, you can see it there as well. So then what I had done is I flagged out some comparison points of some of these key spots. Okay, so you can see in the middle here, we're out by 0.282 inches. Over here, we're out by 0.127. Over here on this side, we're out 0.16. Over here, 0.2. So we can definitely see. So I've just picked kind of the low points to get a few deviations. Okay, so we've definitely got some problems probably with our design. Now let's go ahead and so then what I did was I cut some sections through. Let's turn off the scan data for a minute. So then I cut some sections, and I'll just turn on one of them right here. So if you look here, I cut a section right through here. Now let's turn off the CAD file for a minute, and let's go into a top view and take a look at this. So what are we looking at here? So the solid dark line is the CAD file, and the dashed line is the scan data from the actual bottle, after we took it out of the mold. So you can obviously see what's going on. We've got some serious warping, and we're just not holding the shape. So we can walk through and look at these sections at different heights in the bottle. So this one here, let's turn on for reference. Okay, so that one's up here at the top at kind of this ridge. So that one looks pretty good. Up here, let's go back down in. But certainly these down in this area, let's take a look at this one here. We've definitely got some issues. So we've got quite a bit of deviation from our from our bottle. And you can go in and measure this. You can do GD&T. You can do a lot of things, but it's really not necessary for this. It's pretty obvious we've got issues. And another way to look at it, let's turn this off for a sec. Let's go back to the bottle first, okay? And let's go ahead and select on the mold, and let's calculate the volume, which comes out to 100, let's just call it 185.5. That's the cubic volume of the bottle. And let's turn on the scan data, And let's calculate that. Oops, the measured data. And let's calculate that and see what that volume is. And that's about 175.5. So it's about 10 cubic inches of volume, which equates to a little over 5 fluid ounces of material that theoretically will not fit in this bottle. So if we had to get to, whatever it is, 96 or 128 fluid ounces, we may not be able to fill this bottle, depending on how much it's going to flex. But basically, this just tells us it's a poor design. This really needs to be redesigned to, better accommodate the juice in this, in this bottle. So this is a great way to be able to go in and quickly scan the bottle, import that scan data into inspection software, and do some quick checking, and we could say right away, hey, look, we've got some real problems with this. And again, let's just say our tolerance amount that it can change is 0.05 inches. We can quickly see, this isn't going to work. We've got some real problems. So that's one way to use inspection. Of course, you can inspect the tool, and you'll want to do that. But then we can also actually inspect the parts coming out of the tool, because even though our tool may be accurate, obviously our design is not good because we're getting a lot of deformation after the part is molded. And finally, we're going to look at how you can use 3D scanning for things like design review, marketing, and promotion. So if you were to take a look at this, a lot of people would think this is a photograph of a bottle of sanitizer, when in fact this is nothing more than 3D scan data. And what we did is we took this bottle, we 3D scanned it, then we took it in some software and added some different colors and textures and put a label on it. And this allows us to basically create marketing materials, different concepts maybe for what the label would look like, different colors of the material, things like that, without actually having a CAD file. So let's say you're going to redesign the packaging for it, or you want to get some marketing started, and all the customer has is a bottle. Well, you can 3D scan that bottle, and then you can do rendering like this, or in this case, we just brought it in with a photograph and rendered it up. So let's show in a little more detail how some of this is done. So here we are in KeyShot, and there's the background, which is just a photo, and then here's our bottle right here. So you can see I can rotate it, I can move it any way I want, get it where I want, reflections, the lighting. I mean, you can do quite a bit. And we use KeyShot, but there's lots of programs out there that do this kind of stuff. But they can import scan data directly, and we can assign different colors and put labels and do different things like you see here, and then render it or animate it. So let's go into a little more detail and show you how this is done. So here is that juice bottle, and you can see I've got a label on it. I've got a glass of the juice sitting here. So we're going to use this as an example. To do that, we're going to go back into Design X, like you see here. And again, this is the original scan data of the bottle. And then what I've done is I've actually broken it up. Okay, so let's hide the cap for a minute. And what I did was I cut the bottle right here because I want to apply two different materials. What you see in purple would have the juice in it, and then this top part would just be clear. So what I'm doing is I'm trying to imitate, a bottle that's almost full with juice in it. Now, I didn't have a cap for the bottle, so that I did go ahead and just make in CAD right here in Design X, and that was very easy to do, and just make a pattern. Okay, and then for the cup, what I did was there's lots of websites out there you can go and download all kinds of stuff, and so I went and just found a juice cup on the internet, downloaded it, and then the same thing. I just split it into two pieces to imitate, the cup being filled up to here. Now, there may be other ways to do it. This was just the way I figured out how to basically do it so that I could render it. So once I have all this, I just save them out as STL files. Okay, so here in KeyShot, you can see what it looks like again. And again, this is just the data we had there in Design X. So let's show you a little bit more about how we did this. So, we've got our components over here. Let's say we want to render this again, this time with the cap off. And maybe we want a different color juice, so I'm going to apply. These are all just tons and tons of different materials. I'm using a clear plastic, which basically looks like juice. So I've applied that material to it, and then obviously if we're going to do that, we're going to have to apply that to the cup as well. I don't want to associate them. I want them separate. And then obviously we've lost our label, so I'm going to double click on the material. And then for the labels themselves, you've got plenty of options. You could create them in Photoshop or some other software. I just took photos of the labels. When I took them off the bottles, I just took photos of them. Here's the whole label, and then I just trimmed it up, for example, here. And then you just come here and you just figure out how you want to map it on. You can rotate it around. You can, get it exactly where you want it. Square that up. And we will scale it down a little bit. And just for time, I'll just kind of do this quickly. So let's just say there's our label right there, and then we hit OK. And you can see we've got our label on our bottle. And then we can go in and you can wrap it all the way around. You can do whatever you want. You can have multiple labels. You can come in to your environment, and make it darker or brighter. It's literally endless. Change your background, all your different lights, etc. But once you get it the way you want, in this case, again, we have a photo, so we just got to kind of try to make it look, somewhat aligned to the table. We're doing a nice little reflection here, and then we go and render it or animate it. So again, the point is, without even having 3D CAD yet, if I have a bottle, I can 3D scan it, and I can bring it into software like this and animate it, render it, and do all kinds of neat stuff, to whether it's to start promoting it or to look at different maybe changes in the design, the label, the color, etc. So it's just a great way to be able to do some different marketing and design review and other things by working right with the scan data that you can render and animate.
So this wraps up the video on 3D scanning bottles, and hopefully you found it informative about not only the scanning, but some of the downstream applications like blow molding or packaging or inspection. Now, if you want to learn more, perhaps have EMS do some 3D scanning for you, or maybe you want to buy your own 3D scanner and do this yourself, you can call us at 877-845-2700, or in the description below is a quick link. You fill that out, that'll go to us, and we'll get in touch with you and find out more about what you are looking to do. But this wraps up the video on 3D scanning bottles.